Welcome to our second episode on electromagnetism, one of the four fundamental forces of physics. Like I said last time, there are two aspects to electromagnetic force. Electrostatic force, which builds up a charge in an object and can travel in the form of an electron stream, and magnetic force, which is responsible for the way magnets work. But even though their effects look very different to us, they are in fact one and the same. Hopefully you remember that electromagnetism acts on objects that have electric charge. This charge creates a field around an object, but a magnetic field is a little different from an electrostatic field. For starters, unlike a charged particle, which can either be positive or negative, a magnetic field has both a positive and a negative area, what we call north and south poles. Magnets always have both poles, no matter how many tiny little pieces you cut them up into. But magnetic poles interact very much like single-pole charged particles. The same poles repel each other, and the opposite poles attract. And just like with electrostatic force, because it's the same force, magnetic force is carried between objects by photons. To demonstrate that electrostatics and magnetism are, in fact, effects of the same force, you can create magnetism using electricity. A simple electromagnet is just a coil of wires which, when a current is passed through it, generates a magnetic field. You can make one yourself by passing an electric current through a wire wrapped around a nail or a screw. Switch on the current, and the screw becomes a magnet. Switch it off again, and the magnetism disappears. The magnets on your fridge are made basically the same way, only with a lot more electrical power and using special materials to retain the magnetism. And hey, you know what else is an electromagnet? You're living on one. The constant churning of the molten iron in the Earth's outer core creates electrical currents, and those currents generate the Earth's magnetic field, which has proven to be super useful for things like navigation, and since the magnetosphere is what protects us from solar wind, not being dead. So if an electric current produces a magnetic field, the reverse must also be true. And in fact, yes, you can generate an electric current using a changing pattern of magnetism. If you put a coil of wire within a magnetic field and continuously spin the wire or the magnet so that the magnetic field inside the wire fluctuates, electricity will flow through the wire. And this is really exciting because it's the reason why we have electricity. All you have to do is keep the wire or the magnet moving and you'll have a continuous source of electricity. Stop moving and the electric current will stop. This is how pretty much every source of electricity in the world works, from wind turbines to hydroelectric dams to coal and nuclear power. The only big exception is solar power, which is really interesting, so we did a whole episode on it. Which brings us to the conclusion of our series on the four fundamental forces of physics. If you have watched all of them, now you are a master. Not quite a master, but you're getting there. If you don't feel like you've quite mastered them, you can go rewatch those episodes. Also, we'll suggest some books down in the comments that you can continue to develop your understanding of the stuff that makes the whole world work. Thank you for watching this episode of SciShow. If you have ideas or suggestions or questions, please leave them on Facebook or Twitter for us to see, or in the YouTube comments below. And if you want to keep getting smarter with us, go to youtube.com/SciShow and subscribe.